And good afternoon, everyone. My name is Justin Dyke with the Tualatin Valley Water District. I'm our communications director, and I wanted to first of all thank you for spending your lunch break or your lunch time with us today for Talkin' Water. It's our second Talkin' Water of the year, and if you're anything like me, this change of weather and the increase in sunshine has led us to a great topic today that means warmer days are ahead. We're going to learn a lot about spring irrigation preparation from some experts today. Before we get started, just like to have a couple quick reminders. These sessions are recorded. They're placed on the district's YouTube channel for anyone who's unable to join us live today. But also, if you are here live with us and you want to take notes and some things that you might have missed, this presentation will be on YouTube within the next couple hours after it's completed. We encourage you to go back and reference the expertise that you hear from our hosts today and take advantage of this information. So also, please make sure your microphones are muted, and we will have a moderated Q&A after the presentation. We will stick around to make sure all the questions are answered. To participate in the Q&A later, there is a red circle around the raised hand function on the left there in front of your screen, and as well, there's the mute function all the way to the right on the right circle. We can use those functions for the Q&A period so people can interact directly with Steve and Cal, who are our experts today. And as well, there's a Q&A thought bubble in the middle circle. If you have a question, you don't want to risk forgetting it, please go ahead at any time. You can type those into the Q&A function. We'll read through those during the question and answer period after the presentation, but at any time today, you can type in your questions. That's wonderful. We do have some accessibility features. If you see the 3-dot ellipsis in the bottom left of your screen, that is a function that you can click on, and it'll either magnify or translate or do other things to the slideshow just for your individual view. It might help your viewing experience, but it won't change the viewing experience of anyone else attending today's presentation. So please take advantage of those features as well. And as a reminder, TVWD operates in an inclusive and discrimination-free manner to serve our customers, and staff may exclude participants who disrupt the events today. So without any further delays, because I'm frankly not the expert that you're here to hear from, that was hard to say, I'd like to introduce Steve Carper, our conservation technician, and a little bit later in the presentation, you'll hear from Howell. He's our senior water quality inspector. These two gentlemen are going to guide you through a lot of great information about spring irrigation and what to know as you get ready for irrigating your lawn, your garden, and so forth this spring season with these warmer days ahead. So without any further delay, Steve, please take over.
Thanks, Justin. Taking control here, and good afternoon. Thank you, everybody, for joining us this afternoon. Here to talk about becoming better irrigators, and we'll just jump right into getting that done. To help out with your spring irrigation preparation efforts, we put together this presentation that we do every spring to help folks be more efficient throughout the season. As we go through the process today, keep in mind that really no two irrigation systems, sprinkler systems are the same. So it's likely that your system will have some unique aspects and challenges that we might not address specifically today. So please, if we don't touch on your issues, have your questions ready at the end, and we'll try to address those when we get to it. But the first thing, if you want to be an efficient irrigator, you've got to do a spring tune-up walkthrough every year. Irrigation systems, landscapes are dynamic environments. Things change. Kids play out with irrigation systems. Dogs chew on things. Mowers eat them up. It's really important to at least once a year get out and do a tune-up. Ideally, you're going to be doing a mid-season walkthrough as well, and then in the fall, some sort of a winterization, fall shutdown as well, so that you're able to hit the ground running in the following spring. But at minimum, you want to get out in the springtime and go through, give yourself a good tune-up, and that's what we're here to talk about today, how to do that effectively. Let's see. There we go. You're going to need some basic tools to get the job done efficiently. There are a few specialty items that you might not have out in the garage, but even those are pretty easy to access by visiting your local hardware store. And oftentimes, some of the more specialty tools are easier to find online or by going to an irrigation specialty supply supply house like Ewing Irrigation or Horizon, to name some of our local suppliers. A large screwdriver is going to be really helpful for you to access some of your valve boxes. Some of those lids over the season can become kind of set in place, and with soil and mulch and things getting in the side, a large screwdriver, flathead, heavy gauge can help you open those lids a little more easily to access your control valves. A small flathead screwdriver, something, there we go, we can kind of see it here, maybe a little bit larger than a typical eyeglass adjustment screwdriver, but a small flathead screwdriver comes in really handy for adjusting some of the most common sprinklers that folks are going to have in your yard, which are the sort of pop-up spray heads that I'm holding. This is a clear demonstration version here, but the fixed spray, either like quarter circle, half circle, full circle, very common sprinklers. This little screwdriver will be really helpful for cleaning out the nozzle and also adjusting the radius, or how far the water goes away from the head. That adjustment is accomplished with the little screwdriver. Specialty tools for some multi-stream rotors, MP rotors, things like that, single stream rotors. Those are available. Sometimes you can get them at the box stores when you're purchasing the individual sprinklers, but that may be something that you need to go online or to a specialty shop to find. And I'll have pictures of those later in the presentation to give you a better idea what we're talking about there. A small hand spade is really helpful for doing this type of work, because generally we're talking about making modest adjustments to sprinkler heads and their height and their alignment. So if you're trying to do this type of work with a standard bench shovel, you're going to be generally moving and disturbing a lot more soil than is necessary to get the job done. A valve key is a specialty tool to open and close a specific type of valve that some folks will have. And I will show, again, images of both the valve and the key later in the presentation, so you know specifically what we're talking about there. Gloves protect your hands from superficial nicks and cuts, particularly once your hands start getting soft as you're out there playing with more and more nozzles and getting wet at the same time. Flashlight's going to help you see down into the dark valve boxes so you can see what's going on and get your work done more efficiently and be safe if there are things that you don't want to encounter down in that valve box. And if you're like me and the knees are getting a little long, a little bit of knee padding, a little garden pad, something like that, so that you can be a little more ergonomically correct as you're and comfortable as you're trying to get this work done. These things will help you be much more efficient and comfortable. So the first thing you want to do is to go through the system and make sure any manual drain valves that may have been left on from last year's winterization process are closed. Now, not all irrigation systems have drain valves. In fact, I would say more don't have them than do. But it's something that you want to assess for your system to make sure either way that either you do or you don't. So if you do have them, you can get them closed, because it's a bummer if you charge up the system and you just have a gusher into your valve box. It makes it kind of a mess of everything. So what you're going to be looking for is typically a drain valve is going to be installed at the end of a valve manifold or next to a backflow device. And we've got some images here. On the left, this is a valve manifold under construction. They're not going to look like this when you see them. It'll look more like this over on the right, in the wild environments of your yard. But just to give you an idea of what's happening underground, here's your main line coming in, going to 3 different electric valves that control individual zones in your system. And sometimes if a drain was installed, it'll be at the terminal end of the main line. And in this case, what we see is a typical, like a spigot on the side of your house with a little gate valve handle on there that clockwise closes and counterclockwise opens it back up. So that's what that is. So again, you just want to kind of righty-tighty that valve, make sure it's closed down. Over on the right, we see a valve box that has a double check backflow device. And sometimes a drain valve can be installed at this point as well, right next, just downstream of the backflow device. And in this case, what we see is a crosstop valve. And there's a key, that's the valve key that I mentioned in the first slide, that is used to open and close this type of valve. You can do it without the key, either with a good sturdy leather glove. You can get a hold of that, or even a pair of standard pliers. But it's best practice to have the key. So pliers or channel locks, something like that can damage the valve over time, and it's not really comfortable to open and close these with by hand. So it can be done, but get the right tool to make that job a little bit simpler. Sometimes drain valves, generally whether it's a ball valve as shown here on the left or a gate valve shown here on the right, some of these come with little drain ports on the side. So you want to verify if you do or don't have this type of product as well. If you do, you just want to make sure that this little cap is, again, clockwise to tighten, counterclockwise to open. Make sure that that's nice and tight. Even get a hold of it with a plier and give it a eighth or a quarter of a turn just to make sure it's nice and snug. You don't want to over tighten it, but you want to make sure that that's nice and snug, because if that gets blown off with water pressure, it can be really difficult to locate that in a muddy valve box. So really, you want to make sure you've got that buttoned down. Here's again the common types of valves that you're going to be looking for. On the left, this is a ball valve with a drain cap installed. The way that these operate is if the handle is parallel with the line of the pipe, then the valve is open. If it's perpendicular, it's shut. I'm sorry, I didn't see a note. What was the comment there? I'll keep going and listen.
Steve, I think you can keep going. We had one person who might not be able to view the slides. I think maybe they might need to maybe log
Okay.
out and log back in or something. We're testing it to make sure everyone else can view.
Got it. All right, just let me know if there's a problem. I'm happy to pause and make adjustments. So again, the types of valves that you may see installed as a drain valve. In the middle here, we have the typical hose spigot that you might see on the side of a house. These are very commonly used as drain valves. And then again, the cross top valve here. And this is the key that I was referencing. This little U shape here goes over the top, fits in between these little cross tabs, and makes it a lot easier to open and close this type of valve. So again, make sure your caps are tight, your drain valves are closed, and you're good to move on to the next step. So talking about pressurizing the backflow and the system, I'm going to turn the conversation over to my colleague, Cal. He's going to give you some background on operation and maintenance of backflow devices.
Awesome. Thank you, Steve. And pleasure to be here with everybody. And speaking of backflow prevention, the three we see here are the more common types, but there's actually up to 5 different types of backflow preventers, which can be installed on irrigation systems. And in Oregon, and specifically here in the district, these 3 are the most common. On the left-hand side is the double check valve assembly, and this is probably like 95% of what residential customers would see on their underground sprinkler systems. In the middle is a pressure vacuum breaker assembly, which there are a handful of those out there. And then on the right-hand side, these are atmospheric vacuum breakers, which we'll talk about here in a little bit more detail. However, just a more general comment is all backflow preventers, no matter the type, they're designed to accomplish one essential purpose, which is to protect your drinking water and the community's drinking water from contamination. So they all have different types of internal components, and they do this with different mechanisms, but ultimately that's the essential purpose, is protecting your drinking water and our community's drinking water. In this application for underground sprinkler systems, the backflow preventer, it's installed at the point where your irrigation system connects to your home's plumbing system. So this is essentially a mechanical one-way valve that allows water to flow in just the one direction, which is into your sprinkler system, but would not allow water from your sprinkler system to flow back into your drinking water, your home's plumbing, and then of course not back into our main lines. And this is of course only if that backflow preventer is functioning properly So later on, we'll talk a little bit about annual testing and maintenance on these backflow assemblies. So a little bit more detail on the double check valve assembly. It's typically outside in an irrigation box with a green lid is a common thing to see. It might be near your solenoid valves, which control the different zones throughout your property. However, in some cases, there might be some homes where you can find these in more unique spots, like in crawl spaces, in basements, or garages. However, the majority of the time, they're going to be actually in the ground in these valve boxes. The pressure vacuum breaker assembly, as you can see here, it's installed above grade, and that's actually a requirement, which is why they're not as common in Oregon because of the freezing temperatures. They actually have to be installed 12 inches above all of the downstream piping. So considering every single irrigation spigot or sprinkler head would have to be considered when measuring that 12 inches. So in this case, you can see it's much more than 12 inches, which may mean there's elevated sprinkler heads in that landscape. And that installation requirement, I won't go into the details why, unless you have questions on it at the end, but that is actually essential in how it stops backflow. So if that assembly were to be put into the ground by mistake, it would actually not be able to stop backflow properly and can lead to contamination. On the right-hand side, the atmospheric vacuum breakers. These, similar to the pressure vacuum breaker, are also always above grade. However, you'll have one atmospheric vacuum breaker per irrigation zone or solenoid. So as you can see here in the picture, there's a whole series of them because there has to be one atmospheric vacuum breaker after each solenoid. And these have to be 6 inches above all the downstream piping, which also prevents them from being used too commonly in Oregon, also because of freezing temperatures. And another really important installation requirement for these ones is there can be no downstream shutoff valves. So there's actually been some of our customers that have reached out and asked that I would come out to look at their atmospheric vacuum breaker setup, and we actually have found in several cases where downstream of a single AVB are all of the solenoid zones, and that is actually an incorrect installation and would not stop backflow properly, which could lead to contamination. Regarding the double check and the pressure vacuum breaker assembly, these are testable assemblies which require annual testing. And so these two specifically have test ports and shutoff valves, which we'll talk in a little bit more detail here shortly. And these test cocks and shutoff valves are part of the components which allow the assembly to be tested. The atmospheric vacuum breakers, they only require a visual inspection when they are first installed and if they're ever moved or if there's any significant irrigation modifications. And if you have these types of backflow preventers on your property and wanted someone to come and take a look at their installation, we would be more than happy to do that. On the next slide, I'm going to show you some basic operation of the shutoff valves and test ports of the double check valve assembly so we can begin speaking of pressurizing your irrigation system. So there are two shutoff valve handles, and if you're watching the screen, I have my laser pointer up. So as you see on the assembly, there are these green handled shutoff valves, and there are 4 test ports. You can see these 4 test ports here, which looks like there's a screwdriver slot. And it's important to determine your direction of flow. So you can look for an arrow on the backflow assembly, which shows you whether the water's flowing left to right or right to left. In this case, you might be able to find this arrow down here, which shows it's flowing left to right. However, as you can imagine, down in the dirt, it could be really hard to determine that. And so kind of a better rule of thumb is when you look at these 4 test ports, there's always going to be one of them which is on the outside of one of the shutoff valve handles. So in this case, we can see this one is kind of out on its own to the left of this shutoff. So that's test port 1, and then they follow sequentially 2, 3, and 4. And water always flows in the direction from test port 1 towards test port 4. So if you can't locate that arrow, just find that test port sitting off by itself and know that it's flowing in the direction from that one towards number 4. Test port operation, this is where you are going to need a flathead screwdriver, as Steve had said. They will actually rotate endlessly in either direction, so it's not like righty-tighty, lefty-loosey like with certain things. That screwdriver slot, when it's fully closed, as you can see here, it is perpendicular to the test port. When it's fully open, it's going to be in parallel with that test port. And as you can see with these 4 in the middle picture, they could be in different varying positions. I would just, to play on the safe side, if it is not completely perpendicular to the test port, you would want to assume it's some degree open. And so make sure you close that up, as we're going to go over here shortly, in the order that we want to operate these. The shutoff valves, similar to the test ports in that when the shutoff handle is perpendicular to the shutoff valve itself, it is closed. And when it is parallel with that shutoff valve, it is open. And these, however, should have a stopping point. However, that stopping point can sometimes break off, and you may end up with even a shutoff valve that can endlessly rotate in either direction. So if your double check is still winterized, it's possible that your test ports and shutoff valves are, as of right now, in various positions. And you may have drain valves left open, test ports left open, shutoff valves left open or closed. And so in the next slides, I want to show you the proper order to open these valves and close the test ports to make sure we don't soak ourselves down. My wife and I actually over the weekend took our son to a birthday party, and on our way to the birthday party, I saw a gentleman down in a green box. This is just last weekend. And I saw him reach his hand down in there, turn something, and then a geyser of about 15 feet got him in the face, was flowing right up into the sky. And I knew exactly what had happened, that one of the test ports were left open. He opened up a shutoff valve, and he was in a panic. I was able to pull over and help him resolve things. And I showed him just this, how to close the test ports properly. And so that stream doesn't just get us wet, it would be able to flush contacts off your on your eyeballs if you wear contacts, and could be definitely a little painful. So we want to make sure we do this properly. So Steve mentioned earlier the irrigation isolation valve. We'd actually want to locate this before we start turning things on our backflow assembly. And so the irrigation isolation valve, it might, as we can see on the left-hand side, be in a cylindrical type box, where it's going to also have a green lid that will be flush with the ground and have some type of shutoff valve in there. It may also be inside of the backflow box itself, which you would see upstream of the backflow assembly. And in some cases, you might not have an irrigation isolation valve, in which case the shutoff on the backflow assembly itself would be used for the irrigation isolation. So in here, as Steve already covered, there's different types of valves, from the crosstop, the circular handles, which operate righty-tighty, lefty-loosey, and then this bottom left hand is a ball valve. And then you might run into a situation like this where it's a mystery until you reach down in there. So use a flashlight and a screwdriver to see what you're doing and clear out those cobwebs. So before opening this shutoff valve to pressurize the irrigation, we first want to condition our assembly properly. So we actually want to start with everything closed. So as it's in various positions at the moment, you'd actually want to close your number 1 and your number 2 shutoff valves. You want to close all 4 test ports. Then at step 3, here's where we want to find that auxiliary shutoff, if we have one, that irrigation isolation valve, and open that, which is going to introduce pressure up to the backflow assembly. Then we want to open this shutoff valve number 1, which pressurizes just the backflow assembly components. And once that's done, then we're going to open shutoff valve number 2, as we see in the third picture. Now, this is important to do slowly because this is actually going to introduce pressure up to your solenoid valves. So if you do that too quickly, you can water hammer the solenoid valves and cause some damage. I won't go into too much detail at the moment for the sake of time. However, if you have questions about how to do a leak detection test during this process, we can watch the dial, or you can watch the dial on your meter. There's a little blue snowflake or triangle on your meter. And if you make sure there's no water consumption in your home, no valves open, no sinks or toilets flowing, while you're doing these steps, you can detect if there's a leak in your irrigation system, if there's movement on that meter. So make sure you ask that question for more details at the end, and we could dive into some more details on it. So a few quick words about annual testing. So the district and state rules require that all backflow assemblies are tested annually to confirm they're operating properly and effectively protecting the drinking water. As a district customer, there are two ways to accomplish this test. You can hire your own state certified tester, or you can subscribe to the district's Gold Plan annual testing program. First, let's go ahead and talk about how to find your own tester, because if that's the avenue you want to take, that is absolutely fine. Just keep in mind that all testing is due before September 1st of each year. However, you can feel to complete this much earlier. So a lot of people would hire a contracted tester to complete their test in the springtime. So like April coming to May as they're getting their system fired up for the season. In fact, if you hire a company to do that for you, they may also offer a testing service. To find a tester, although there is a state website, which we're more than happy to put into the chat, it can be a little bit daunting. It's an exhaustive list of public testers that the state provides, and sometimes you have to call 2 to 3 companies before you find somebody that would come out to you. So it's actually better to just ask your neighbor, ask friends in the area, Googling a company. Some things like this would give you a good idea of some testers in your area. It is the tester's responsibility to submit the test to Tualatin Valley Water District. And so although they'll give you a copy for your own retention, they actually submit that to us electronically through our backflow software. Now, if September 1st comes around and an assembly is not tested, we don't have passing results submitted prior to that cutoff date, at that time, we would actually apply a $65 enforcement charge to that water bill for the untested assembly, and we would send out a contracted tester to complete the testing under that cost. So essentially, although it's an enforcement fee, the assembly is getting tested for that $65 charge being brought back into compliance. So onto the Gold Plan program, which has actually been offered since 2009. It's an optional service for most residential customers. Currently, we actually have over half of our residential customers who have backflow assemblies who are in this program. So we're just over 10,500 customers that are being tested under the Gold Plan program. The program, it's designed for readily accessible assemblies in locations that don't require appointments. So if you do have one of the assemblies that are in crawl spaces, garages, these types of locations, it would be more suitable to schedule a test with an independent company. To subscribe to the Gold Plan, you can go to our website and apply there with an online application, really simple to fill out. And then we would send you a confirmation email. Time is definitely of the essence right now. We are coming up on our cutoff to be included in this year's testing. So if you do want to read more and subscribe to the Gold Plan, make sure you do so before May 31st. If you subscribe after May 31st, your Gold Plan would become active next year, and you would still need to hire a tester before September 1st of this year to complete 2025's annual testing. The Gold Plan is a $35 charge that we apply to the water bill once per year, and we consider it a subscription in that we apply that bill all towards the beginning of the year. And so when you see that charge on your bill, it does not mean your assembly has been tested as yet. but will be tested some point between April and September of this year. And we work right now with 4 companies that we will basically assign your test to one of these 4 companies, and they will route the testing, get it completed. They submit the results to us. And if the assembly does need any repair, we offer a $50 credit towards that repair work if you work with that contracted tester. Okay. So make sure you ask your questions for me at the end, because I'm going to kick it back over to Steve for now.
All right, thanks, Cal. So moving back onto the irrigation system, this is just a nice general overview of what a sprinkler system layout is going to look like in the best situation. Now, nobody has one that looks just like this. And again, no 2 irrigation systems are the same, but this is really provided to give you an idea of the order of operations in kind of in ideal conditions. And what I really hope you take away from it is just, kind of the general layout. If the water service coming in, let me switch over to the pointer here, through the meter box, then your main line goes into the house. At some point along the main line, you've got your point of connection that comes out to the isolation valve, which is a gate valve or a ball valve that may or may not have a drain port attached to it. Sometimes, again, all of these components, depending on who installed it, are seen as optional, unfortunately. So if you can't find these in your system, don't fret. There's usually some type of a workaround. For example, if you don't have an isolation valve here, sometimes the number one ball valve on the backflow device is used in lieu of that to isolate the system. Not best practice by any means, but that is often your only resort until something like that can be installed. Moving through the backflow device, which, as Cal talked about, can either be an AVB, a PVB, double check device. Sometimes they're above grade, sometimes they're subgrade. Just you got to learn what you have and learn how to maintain it. And Cal's information was really helpful, regardless of what you may have on your system. Moving on downstream, we run into a pressure regulator. Now, in our area, be a very, very useful thing to have, and very few irrigation systems actually have them installed dedicated. Most irrigation nozzles are designed to operate at a range between 40 and 65 psi, ideally. It is not uncommon for us to see pressures 85, even 100 unregulated at my house. I have to do pressure regulation, and that can have a big impact on performance and efficiency. So pressure regulation is something that can be really beneficial to the optimization of your system if that's something you're considering. Some systems have a master valve that will prevent any water from being in the main line unless the system is under operation, and that is generally controlled by the automatic controller. When an irrigation zone is activated, the master valve is activated to provide water supply to the system. Continuing on, the main line goes downstream to the individual zones, or the solenoid valves, as Cal mentioned. Going over, we see the irrigation controller is generally installed in the garage or on the exterior wall near a garage, but not always, but those are the 2 typical places. I'd say most commonly in our area, they are installed in the garage. And we'll talk a little bit more about the specific operation of a controller a few slides from now. But then you come to a typical rectangular valve box, which has anywhere from 1 to 4 individual control valves that operate the individual zones on your sprinkler. And then from downstream of your solenoid valve, we call those the lateral sprinkler lines, where it goes down to whether it's a single stream rotor zone or a multi-stream rotors or pop-up spray heads that are in fixed pattern. The idea is you don't want to combine different types of sprinklers on the same type of zone. It's best to use the same type of sprinklers on individual zones, and then that's a great way to differentiate between areas. For example, single stream rotors on turf because they can cover a greater distance. And then when you're looking at your shrub and tree beds, then perhaps pop-up spray heads or multi-stream rotors are more effective. But it's best to not mix various types of sprinklers on the same zone because they have different rates of water application or precipitation rate. So that's one way to really improve the overall efficiency. Here you see an example of a drip zone, and the thing to keep in mind with drip is there's some special equipment that has to go into a valve box. So typically, if you have a drip zone, it has a dedicated box because you have typically a filter and a pressure regulator installed just downstream of the control valve. Drip equipment is manufactured to operate at 30 psi or lower, somewhere between 15 and 30, and you'll have a special type of pressure regulation device that goes in there. And because you have that extra equipment, it takes up more space. You want to be able to get in there and maintain it. It's best to have a dedicated valve box on a drip zone so you can do that. The filter is something that is best cleaned out annually. So it's typically a little Y filter that you can unscrew the top when the system's not running, obviously. Tap that out, flush it out, replace it back in, and you're generally good to go. It's important because most drip emitters are very small orifice, so the small amount of silt that can be in the natural water supply over time can build up and impede the performance of that equipment. So a filter is really an important piece of drip. So we're going to move on here. Now it's time to take a ride in the Wayback Machine, and we're going to watch a little video about the typical things that you want to pay attention to and maintain and adjust every year. So here we go. Go back to the selector here. There we go. See if I can blow this up. All right, I'm going to go ahead and pause that at that point and we'll move on. If anyone had any trouble, I think Frank put a link to the video. If you had any issues with the video or the audio, apologize for that. Let's see, there we go. So moving on, we're going to talk about the irrigation controller, and by far and away, this is where I see the most issues, where I'm helping customers in August and September. I start getting phone calls when folks get their bills at the end of irrigation system season, and I go out to help them assess what's happening. And 8 times out of 10, it's a misprogrammed irrigation controller. So it's really important to understand how yours functions and do your best to get it programmed properly. When you first approach it at this time of year, it's hopefully in the off position from last year's winterization procedures. Whether it's an indoor and outdoor mounted controller, keep in mind that most units are going to have similar functionality, but different user interface. Typically dials, buttons, or touchscreen layout. I recommend looking on the inside cover and seeing if it has a quick start guide. Get yourself familiar with that so you know how to do manual starts of individual zones or programs, just to get a base understanding. Look in there as well, or look behind the controller to see if the actual manual is present. Please read the manual. Again, become familiar with this because it really is the easiest way to avoid an unnecessarily high water bill at the end of the season. So the first thing we're going to do is turn it to the on and the run position. Depending on the programming from last year, you may need to make any adjustments to the start times and watering durations if you have a traditional irrigation controller that's not a Wi-Fi or a smart controller. That's kind of the new generation, and we'll talk about those in a little more detail at the end. But just to kind of address the more typical controllers that we've seen over the past 10, 20 years, highly functional, have a high degree of functionality, and they also have some problematic things because of that functionality. You want to go through the program to make sure that it doesn't have extra programs that are active. Most of these controllers have anywhere the program A, B, C, or D, anywhere from 1 to 4 programs. In each program, you can have as many as 4 start times. You know, not all of them have 4, but many of them do. And then for each zone, you're able to set the run time anywhere from 0 to 2 or 3 hours, but generally 10 to 20 minutes, depending on the type of sprinkler that's installed. So you can see, hopefully, the opportunity to misprogram these, particularly when you're talking about a device where you've got a little, 1/2 inch by 1 inch LCD window and a dial. It's easy for folks to get confused and not realize that you've got 4 programs and now you've got 2 start times that are activated for each of those programs, and you've got run times of 10 and 20 minutes on each of your zones, and you've left it active on every day of the week. And it may seem silly, but I've seen this in the field where you've got customers that are watering 7 days a week, 3 times a day, and they're telling me there's no way I use this much water. And if I do a simple, flow rate calculation, measure the flow rate, and then apply it to the schedule as it's programmed into the controller, it's pretty easy to demonstrate how that much water can be used. So please become familiar with how your controller operates. Go through the program and make sure you don't have extra run times and start times that are activated, because it can be a costly mistake at the end of the year. The other thing you want to check is there's a feature on most of these controllers called the seasonal adjust. Sometimes it's called the percent adjustment, and sometimes even water budget, not really an appropriate term. But what that does is it's a setting on the dial that allows you to modify a percentage. Sometimes it's in increments of 5% or 10%, but when you turn the dial to percent adjust, generally it'll say 100. And if you scroll up or down, what it does when you turn it back to run, it recalibrates the entire program based on how you've changed that setting. So for example, if I am at 100% on my seasonal adjustment, the controller will operate exactly as I have it programmed. If I change it to 110%, it's going to increase everything as it's programmed by 10%. So it's a simple way to calibrate the entire program up by 10% if it's a hot week, and then turn it to run and be done with it. So without having to reset each zone. Or conversely, if it's a cool, milder week, you can turn it down to 90 or 85%, and it's going to again recalibrate the entire program, reduce it by 15% without you having to redo each individual zone, which can be significant if you're talking about more than 3 or 4 zones. So just make sure that that's at 100%, and then you know it's going to perform exactly as programmed. Radius and arc pattern, we touched on that in the video, and the way again that is typically done with a pop-up spray sprinkler is using the little flathead screwdriver. There's a little screw. I go to my pointer here on the top of this nozzle, and if you clockwise tighten it down, you're gonna close the little valve, if you will, in the top of that nozzle, and you're going to reduce the radius or the distance that the water goes away from the head. If you go counterclockwise, you're opening it up. You're going to increase the radius of the water going away from the head up to the manufactured throw of that nozzle. They typically will come in 5, 10, 15-foot radius sizes, and they're often color coded by that size or by the radius of the throw. On a multi-stream rotor, which are becoming more and more popular because they're wonderfully much more efficient in terms of uniformity of how the water is applied. But there's a specialty tool that typically comes with a pack of larger nozzles when you buy them. And similarly, there's a radius adjustment in the top that you use a little screwdriver-like feature at the top of that tool. And then this round piece fits over, and opening or closing can actually modify the arc or the pattern that nozzle applies water in. Single stream rotors are similar in that they require a specialty tool to make the adjustments and actually pull the sprinkler body up, pull the rotation piece, the stem up out of the sprinkler body so that you can make these adjustments. Similarly, there's a screw that goes down here that will interrupt and diffuse the stream of water coming out of the sprinkler that can have the effect of reducing the radius. And likewise, if you counterclockwise that screw and remove it out of the spray zone, it will concentrate that stream and increase the distance that the radius that it goes away from the sprinkler. So highly adjustable, but you just have to make sure you've got the right tool. And this is another reason why you want to make sure you have the same types of sprinklers on individual zones. And then it's also a good idea to kind of pick one manufacturer that you like or have confidence in and stick with them throughout your system. And that way you don't need a drawer full of specialty tools to make your adjustments. You can kind of focus in on one manufacturer and their approach to maintaining their equipment. They all have equipment that is highly efficient, so it's kind of your choice, whatever you prefer, what's on sale, but it's best to kind of pick one and stick with it if you can. Rain sensors and weather stations, these are great features that not present on all systems, but are a great way to kind of take the next step in efficiency. Rain sensors basically they do what it sounds like. They sense when enough effective rainfall has fallen to inhibit irrigation. That's how they operate. There's a little disc in there that gets saturated. When it gets saturated to a certain point, it tells the controller don't irrigate until it dries out. Then it sends another signal, says resume. Those are really effective in our area in the shoulder months, in the spring and the fall, when you start kind of like now, it feels like we're going to have an early summer. We may need to start irrigating here pretty soon, providing some supplemental watering, but then it's Oregon. We're not quite there yet until July 5th. We're going to have some rain showers coming in where we might not need to water for a few days or a week or so. So it's best to have something like this to help you apply water when it's needed, but not when we don't need it. The next thing is the weather stations. You're seeing these more and more on the new weather-based irrigation controllers or smart controllers. And these weather stations are actually providing on-site weather data to the controller so that scheduling adjustments are made on a daily basis, whether or not watering is needed based on it's calculating evapotranspiration, which is water that evaporates through the soil or is transpired through the plants. The controller is actually estimating that value based on parameters that you program into the controller. You'll tell it, for example, we're going to set the parameters for zone 1. We'll say we're using pop-up spray heads on turf in clay soils on a flat surface in mostly sunny exposure. And it'll take all those different parameters and use that in addition to solar radiation, relativity, humidity, sometimes wind speed, and all that information will be used again to estimate when does watering need to occur, and it does it automatically. So it takes that human element out of the scheduling, which is really one of the hardest parts of achieving peak efficiency with irrigation. Because, as much as we may want to, very few people take the time to go out and make daily, let alone weekly, let alone daily adjustments to their irrigation controller. So this is really the new state of the art in efficient irrigation. Here we provided kind of a nice checklist for you to take these steps on your own and feel confident. I'm not going to go over each one of these steps because we really kind of covered them in the presentation, but I will guide you to the bottom 2 bullets, one being the weekly watering number at regionalh2o.org. The weekly watering number is a tool if you don't have a weather-based irrigation controller and you don't see yourself making that investment. The weekly watering number is a way to use a traditional controller, teaching you how to program a base schedule of 1 inch per week, and that's kind of generalized across the landscape. That's really talking about cool season turf, which is what we have, grass in our area, and then there's a way to calibrate different types of zones like shrubs and trees. There's a percentage for that, or annuals, different types of plant material to calibrate it to that 1 inch a week base schedule. The weekly watering number is a number that you sign up for it on the website, and then the consortium will email you on a weekly basis throughout the irrigation system. And it's a number, and it comes in inches. And so, for example, this week the number comes out and it's based on the weather, 0.8. And all you need to do is think of that as a percentage. 0.8, 80%. I'm going to walk out to my controller. I'm going to turn it to the percent adjust or seasonal adjust feature, and I'm going to scroll it down to 80%, and then I'm going to turn the dial back to run, and I'm going to walk away for the week. And what I've done is I've just calibrated my 1 inch a week base schedule to 80% based on the number that we provided. That number that we provide from the Regional Water Providers Consortium is based on a regional network of weather stations that we have. We have a contractor that takes that data and produces the weekly watering number based on zip code for folks in our area. So really encourage you to take a look at that. Even if you don't go the whole way, you can. There's got some great information on how to become more familiar with setting a base schedule and just the concept of watering according to what your plants actually need. Again, the next step to take the worry out of scheduling is to, and kind of eliminate that human element of it, is to install a WaterSense labeled weather-based irrigation controller. WaterSense is the EPA labeling program, product labeling program, similar to Energy Star for energy, but this is focused on water efficiency. And products that are WaterSense labeled have perform 20% more efficiently than typical products that you'll find on the market. TVWD offers rebates for WaterSense labeled irrigation controllers of $50. And on the homeowner grade products that you'll find that are WaterSense labeled, that's a pretty significant incentive to help you get those installed and offsetting some of those costs. With that, I'm going to open it up, turn it back over to Justin, and we'll try and address any questions that you may have before we get out of here.
Awesome. Thank you so much, Steve, and thank you to Cal. We do have a couple questions, so I'll start by prompting everyone. If you do have a question you'd like to ask Steve or Cal, please type it into the chat or the Q&A right now. We'll get through a couple of these. We only have a few, though, to start. So the first one, Steve, is going to be best answered by you. It's from our customer, Maureen, who writes, is it necessary and how to winterize/drain the system if there's no drain valve? Just open the lowest point sprinkler for each zone?
Yeah, and depending on the type of sprinklers that you have, sometimes, and in fact, is it right? Many sprinklers have check valves in them now that prevent passive draining when the zones aren't pressurized, when the water's actually irrigating. When that stops, many sprinklers now have check valves that will prevent the passive draining. So the lateral zones and then the main line will retain that water. For that exact reason, during the season, we don't want the laterals draining out passively at the end of each cycle. We'd rather save that few gallons and put them on the landscape at the end of each cycle. To the beginning of your question, in our area in the Willamette Valley, is it necessary to winterize? Personally, my opinion is no. Particularly if you have a double check valve backflow device that is subgrade. The vulnerability that you will have in our area, to Cal, as he mentioned earlier, is if you have a pressure vacuum breaker or atmospheric vacuum breakers that are above the surface. At minimum, insulate those, and in most cases you'll be okay. But it all depends on your exposure. In if you go east of the Cascades and certainly farther east in the country, is very common to have contractors come through in the fall and winterize by actually blowing out the system, the main and the lateral lines with pressurized air. Not as common in our area just because the climate is so mild in the Willamette Valley. But you kind of need to make that decision for yourself and based on your own exposure. Do you have a pressure vacuum breaker that's on the south facing wall that takes the brunt of the wind? And you might want to cover that up, or at least get that insulated. But fully draining or blowing out the entire system in our area might not be absolutely necessary.
Awesome. Thank you, Steve. And our next question is for Cal. Customer named Cherie writes in, I will likely be replacing my PRV due to corrosion soon. Do I need to have another backflow test done after that install? This PRV is off the water meter at the street prior to the backflow.
Great question. So there's nothing that requires you to do that. However, it wouldn't be necessarily a bad idea. It could be seen as a good thing to do because anytime there's something upstream that could introduce foreign material into the piping that's not properly flushed out, that could get flushed downstream into the backflow assembly. So such as PVC glue, Teflon tape, metal shavings, these kinds of things that get into the line, they would be able to foul up the check valves and prevent them from sealing that are inside of the backflow assembly, causing the checks to fail. And this is actually one of the reasons that new backflow assemblies, when they're first installed, have a pretty high failure rate. Not really high, but an increased failure rate isn't because there's something inside of it that's broken, but because something needs to be simply cleaned off of the check valve. And so in this case with the new PRV, those same materials could be flushed into the checks, and you want to find out sooner than later to make sure that can be dealt with and cleaned. So more straightforward answer is no, it's not required, but it would be a pretty proactive step to do so to confirm that nothing was flushed through those check valves, causing them to foul up.
Fantastic. And as of right now, those are our only two questions that have been submitted. So we'll pause for a second or two, potentially maybe 8 seconds or so to see if any customers write in with any final questions. During that time, I'll move us over to our last slide of the day with contact information for both Steve and Cal. And please feel free, if you have any other questions, to reach out to these two wonderful guys and ask your questions in the future. And as well, a shameless plug for the future Talkin' Water editions that have yet to be occurred. We'll probably do one in the summer and one again towards the fall. And we have one final question. Looks like it'd be good for Steve. Question is, are pressure adjustments to prevent misting done at solenoid or on the sprinkler somehow?
Yes. Yes. So there's features, there's equipment available to kind of do all the above, and it depends on what you're observing. If it's only on a few zones, then probably the most cost-effective way to address it currently is to replace the sprinkler bodies that have um, pressure compensating sprinkler bodies is basically what they're called. So if you have high pressure coming in, the sprinkler body will moderate the pressure enough such that then the nozzle is going to perform much more optimally, or at least it's going to minimize that misting or fogging effect. If you are seeing it more so across the board on all of your zones, it may be worth considering doing a more systemic PRV, pressure reducing valve, so that you're doing one installation, you're moderating the pressure on the entire system, and then you're done. So you kind of have to do I guess, a little analysis to see, well, how many sprinkler heads are we talking about compared to the cost of that compared to the cost of the one PRV device, and then getting that installed. Are you going to do it yourself? You have to hire it out. So just doing a little bit of investigation and then cost calculating to figure out what's going to be the best, benefit for the buck for you. But definitely, over time, I think the return on investment is worthwhile. That's something I'm looking at home. My wife and I bought a new house last summer, and so I'm going through all this with my new system and have lots of adjustments, pressure being one of them. So I'm trying to figure out what's going to be my best approach. Probably going to be a system PRV because it's just kind of elevated across the board, and I don't want to have to, keep replacing broken gear. And I want things to perform optimally. So again, just observe how your system's performing. If you're seeing the same issue in all the zones, probably best to do one big PRV that's going to address this whole system.
And next question is from a customer named Jeff. I'll handle this one myself. Jeff writes, do water costs differ among counties? If so, why? Yes, they do, Jeff. And not only do they differ across counties, within a county, different water utilities such as TVWD versus our neighboring agencies have different water costs or rates, as we normally call them. That's going to be a lot of the different factors at play, how they get their water, the cost of the water for them to either source it, procure it, treat it, and so forth. Their capital improvement programs, their costs to operate their water system based on its complexities, whether it's, for example, a smaller, flatter water system or a larger, hillier water system with multiple pump stations and reservoirs and things like that, all influence the cost of delivering water to our customers. I'd encourage you to stay engaged with either our TVWD newsletters or other aspects of our outreach, because later this summer, around August, if I'm remembering correctly, we will do another Talking Water on our rates process. We will be going into a water rates setting process for the next 2 years, our biennial rates cycle. So you'll have a lot more information and opportunities to learn exactly what drives the cost of operating TVWD's water system during that presentation. And we'd have the appropriate experts at that time around to answer those more detailed cost and economics questions of running a water system for you. And let's see, there is one more question. We'll ask Steve this one from Michael. Is there an easy way to determine the water pressure?
Absolutely. Unfortunately, I did not include these devices in my visual aids here. But basically, if you go to any hardware store, box store, you can get a pressure gauge, and then you just need to get it attached to basically a hose spigot. You can probably put it together hose spigot pressure gauge for about $10 for the brass fitting. If you're a customer, send me an email. And if you want to pop by and borrow a device to take a pressure reading, we can probably arrange that. We also have one that I've configured that will allow me to place the device on a sprinkler nozzle. So I pull the nozzle off, put this little pressure stem on there, and then put the nozzle back on. So I'm able to take a reading at the irrigation. So I'm getting an operating pressure at the sprinkler head, which is really nice because you can get in the ballpark by measuring the pressure at the spigot, but then you're incorporating more of the plumbing with the entire home into that reading. Whereas if you can get a reading out at a nozzle, you're getting a more true operating pressure, and that's really what the nozzles are dealing with, right? So yes, you can go to any irrigation supply house, again, Ewing, Horizon, and they can set you up with what you need to determine your water pressure. Or if it's something you're just curious, send me an email and we can make some arrangements, help you get it figured out.
Wonderful. Thank you, Steve. And with that, we are out of questions for the day. So as a final thank you to our customers and the audience for joining us today in the middle of their day and their lunch break. And Cal, would you like to say some farewells?
Oh, I pressed that by mistake, but yeah, thank you for attending. It was a pleasure, and feel free to email me with any questions.
Well said. With that, we'll look forward to seeing you all during the summer or the next edition of Talkin' Water. Thanks so much for your time today. We appreciate it.
Thanks, everybody. Happy irrigating.